Okay, yeah. First of all, this topic we will discuss another multi-criteria decision method, so-called Promethee, or it is stand for Preference Ranking Organization Method for Enrichment Evaluation. Yeah, it's quite long abbreviation, but basically what we are going to learn today is more to the basic introduction to Promethee methods. These methods pretty much I can say is a combination about from Topsys and the it's not really a combination, but it's more like how to say, the method will be quite similar with Topsys and Electri. Okay, because they in Topsys we only use the value to compare. In Electri we have several comparisons with the other vectors, but for this one we combine both. Um, in which later we will follow this one using a case study, so that it will be more clear to you. And later on, there is two versions of Promethee, Promethee 1 and Promethee 2, but the step is quite similar. The only difference is that when you decide how to choose among the, we call it action here, that refer to alternatives in the previous methods like AHP and stuff. And maybe next week I will try to provide the implementation of this method using software called Microsoft Excel, which is we calculate manually, and another software divided. It's called Smart Picker, which implement Promethee behind the scene. Okay, yeah. So the first we go to review the essential concept of this method first. Okay, so basically I already mentioned that the the method stand for Preference Ranking Organization Method for Enriched Evaluation. So basically you will provide a ranking. Okay, a ranking among the option that you have. Okay, a methods to give the decision maker the ranking among the action or the alternative that you want to choose. Okay, which the methods that you are using to give this ranking is based on the preference. Okay, based on the preference and enrich evaluation. So that's why it's called like that. And here, the alternative that we are going to choose is called action. Okay, and among of alternatives, we will still have the same comparison of criteria to select this alternative. Okay, for example, last time I remember we discussed about selecting car. So among several car available, which in this method called alternative or called actions, let's say you want to buy a car. The action is to buy, the action is to select a sport car, luxury car, an economic car, something like that. Okay. And from this action, in order to choose or give a rank between this action, you need to have a criteria, right? For example, the criteria is about, okay, let's say talk about car. Perhaps the criteria would be how much the price of the car, okay? How comfortable this car is, okay? And what else? How efficient is their fuel consumption? That's we call criteria to select among this action. Uh, in this Promethee methods, you have three main steps. Three main steps. Which first, we need to have we need to compute. Okay, we need to compute something called preference degree. Okay, so you have an action that we mentioned earlier. Let's say buying car, which the action number 1 is to buy sport car, action number 2 is to buy economic car, action number 3 is buy luxury car, action number 4, let's say buy touring car. First, you need to compute something called preference degree. It means like, okay, compare economic car with luxury car. You need to compare which one you prefer. Okay, this called preference degree. Of course, you need to have the in what base you are comparing these two options or these two alternatives. Okay, this is called criteria we mentioned earlier. Okay, so the first step is to compute preference degree for each combination of pair action. Okay, luxury car with economic car, luxury car with touring car, luxury car with sport car. Based on what? Based on, let's say, criteria 1 is based on the price. Which one do you prefer? And then in the second iteration, you need to also have, let's say you have another criteria that I previously mentioned. For example, comfortable. You compare car, economic car compared to sport car. Which one is more comfortable? Economic car compared to touring car. Which one is more comfortable? Those are called the first step of Promethee. Computing preference degree for each pair of action on each criteria. Okay. And then the second step is to compute something called Unicriterion flows. Okay, this is a new term, Unicriterion flow. Okay, previously we have the preference, right, for each criteria in each order of pair. Okay, based on this table, based on information generated in the previous step, you create a graph called Unicriterion flow. Okay, what is this Unicriterion flow? Simply speaking, this Unicriterion flow will help you depict or will illustrate for you which action or which alternative is preferred one to another for each criteria. Based on the graph itself, you can see, okay, this one will be more preferred compared to the other one. Okay, but only for each criteria. Okay, for, let's say you have 4 criteria. Price, for price, which one is more preferred? For comfortable, which one is more preferred? Yeah, this is the second step. You create a graph of it. Okay, based on that, you can create the last or go to the last step, which is called computation of global flow. Okay, so previously you have comparison between each criteria, right? So then now you want to make decision, but we don't want to make a partial decision, right? Partial decision means like the decision based on only the price or based on only the comfortable of the car or based on let's say fuel consumption of it. We want to consider all of them. So that's why it's called computation of global flow. So from all of those information you already collect, you combine it into one, and this is called global flow. And from that, you will create the ranking. Okay, this is 3 main step of Promethee. Then we can move to the next slides, which basically we will try to implement that 3 basic or three main steps of Promethee using this case study. Okay. Well, here, yeah, fortunately, the case study is pretty similar with what I already mentioned earlier. Here, we want to buy a car. The case study is the selection of car to be to have a decision maker to select which car they prefer. Okay. Buy a new car, and then okay. First of all, we would like to, in order to make it a little bit more simpler, we need to first find a way to break down from a car that you want to buy, what kind of criteria you want to use as the comparison between the car that you want to buy. Okay, let's say here we decide to have 4 criteria. First is the price. Yeah, we want, of course, as minimum as possible. And then the consumption of the fuel. Of course, this is like the measurement is per kilometer. So the higher the better, right? So let's say 10 kilometer per liter, that is better than 77.5 kilometer per liter. Okay. Wait. Is it correct? 7.5. No. For this one, the assumption is not like that. This one, the minimize the better. So it's like 7.5 kilometer, 7.5 liter per kilometer. This one, the measurement is like that. Liter per kilometer. So it's like so the lower the number is the better. Okay, so you want to minimize this one. And then the third one is comfortable. This is a qualitative measure. It's a little bit difficult to derive, but somehow for the example sake, we have derived it into this categorical comfortable level, which is bad, very good, and average. And later on, we will need to convert this into number. Okay, for example, very bad is what number? Bad is what number? Yeah, from 1 to 10, what is bad means? Okay, average is what number? And here we get a clue that this is want to be maximized. So it means that the better the comfortable level, for example, let's say bad is worse, is better than very bad. Okay, or the obvious one, bad, very good is better than bad. So very good should have a greater score compared to the bad. Okay. Let's say if you give very good is 10, so bad maybe about 5 maybe. Yeah. So for example, like here, very good, let's say it is 10, this will be average will be 7, this will be also 7 because the same, this will be 5, this will be 3. This is just an example. Okay, so this is the number that you can give to the score in this case. And then the power, horsepower. Normally people will want the higher the horsepower, the better. Yeah, so it's like here we have the standard number. For example, economic will be 50 horsepower and so on. Okay, after we gather this information, what should we do next? Yeah, of course we will need to understand every the meaning of the number. And then here one particular things you need to ensure is that if you already have an what is it called, an action on our alternative, which is here, We have 1, 2, 3, 4, 5. 5 alternative: economic, sport, luxury car, and touring, with their each 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 data related to their criteria. Make sure you don't have an alternative that is superior to the other of the alternative. For example, here economic may be the best in terms of price, but in terms of consumption, still touring will be still better than the economic, right? And in terms of comfort, luxury car is better than, so it's not superior to the other one. And in terms of power, the sport car will be the best. Okay, make sure you don't have one alternative superior to all of the other alternative. If you have one is superior to the other one, you don't have to use this method. Just choose that one. For example, okay, I have a car, let's say car. I don't mention specifically the case. For example, car, superior car. It means that they have, let's say the price is very cheap, and then consumption is very efficient, 6.0 or 5.0, 6.0. And then this is a very, very good. I don't know what is very, very good means, but yeah, basically better than good. Okay, very, very good. Horsepower is so high, let's say 120. This is mean that this alternative is superior. On each criteria, they are better than the other one. If you have this kind of alternative, you don't need to do this method or any method for multi-criteria decision making. Just choose this one because it is much better compared to the other. Okay. So, well, basically, after you have this information, what you need to do next, remember we have 3 main tasks earlier. First one is calculate something called Unicriterion preference degree. Okay. Okay, now we will go to the how do we calculate this Unicriterion preference degree. First of all, a preference degree, we will give a score 0 and 1. Okay, 0 and 1 based on what? Based on the value on each of the criteria. For example, you have previously we have price, right? Price, okay. And then we compare one alternative, let's say economic car compared to luxury car, okay. Based on their price, you will give a score from 0 to 1 using rules that we will define it later, and then we will call this score as a preference degree. Okay. Okay, the rule is explained here. You have a score from 0 to 1, right? A preference degree equals to 1. It means that you have a total or strong preference. So you prefer this action compared to the other one. Okay. 1 is mean you prefer one action or prefer one alternative compared to the other one. Then you give score 1 to that comparison. Okay. And then if not, if you don't have the preference for this one, you give the value of 0. What about if you have the preference, but not total preference, not very, very strong preference? Then you give a number between 0 and 1. Okay. That's why it is the score is from 0 to 1. Okay. Yeah. Now let's try. Okay. Let's try to give to score the preference degree. Like we mentioned earlier, let's use the first criteria, price. You have 5 5 alternative: economic, sport, luxury, touring A, touring B. Each of alternative with the value of its price. Economic will be 15,000. What is it? Pound sterling, I guess. Yeah. Okay, 15,000. And then sport is 29,000. Luxury is 38,000. Touring A is 24,000. And touring B is 25,500. Yeah, I'm talking about this number. Okay. Okay. Now, let's use the obvious one first. For example, if you compare touring B, not the obvious one, maybe like just one example. Touring B, the price is 25,500. Okay. You want to compare with the luxury, which is 38,000. The price difference perhaps like it's quite a lot, like 13,000. No, 12,500 something. Yeah, 12,500. You consider that a lot. So then you decide that, okay, I will have a strong preference towards touring B. So when I compare touring B with luxury, the score will be 1. Means that touring B have a strong preference to compare to the luxury. Okay. However, now let's give another example. When you compare touring B with touring A, okay, yeah, in terms of the price, you see that the difference is quite small. Okay, and even it's similarly priced. Okay, so in this case, what should you do? Oh, I don't have any preference for this one. Yeah, so here you will somehow select like, okay, I will just give 0 instead of 1. Okay, then how do you decide which one is 0, which one is 1? Okay, there is a way for that. We will use something called function. Okay, we will have linear function. Another one is Gaussian function. Okay, we will study both. But in order to give the score, preference score, we will compare them one by one, so that we call that procedure as pairwise preference degree comparisons. Okay, but when you compare, let's say action A to action B, okay, and then it is you will automatically have the score of the other one, compare B compared to A, something like that. Okay, this is called evaluating the Unicriterion pairwise preference degree. So later on, this Unicriterion preference degree, we will somehow can recalculate again, and then do some experiments about this formula, which is called rescaling or enriching, but we will not give you a clear not really detailed example for this case study yet. Okay, so now let's move on. Okay, in order to give that score, right, between 0 and 1, here you can use this technique. Okay, first is that you need to consider which kind of function you are going to use. There is a linear function, another one is a Gaussian function. Both of them is basically help you to determine what will be the score for this difference between alternative. Okay, for a linear function, okay, it's look like this. Okay, we will have two parameters, Q and P. I will discuss that later. What is Q, what is P, which basically to determine what is the minimum difference so that you will have a strong preference. What is the upper limit difference so that you have the minimum difference so that you have doesn't have preference, which means the score will be 0, and then the upper limit difference, which refer to the upper limit that you can give a strong preference, which refer to a score 1. Okay. However, for the Gaussian function, you only have one threshold. Here we represent it with the letter S, called the inflection point. Okay, so it means that before this point, the preference will be what? After that point, the preference will be what? Okay, so basically that first you need to take is that there is two functions, linear and Gaussian. Next, okay, how we could use these two functions. Okay, first maybe let's use the simple one, P and Q first, the linear function, so that you will not have you will not get too confused with this one. Okay, here you see that we have two parameters, Q and P. Previously, when we calculate the price, right? You need to calculate the difference between one price of car to another price car, and then this difference will determine whether you have a preference or not, right? For example, previously we have economy car is 15,000. I forgot, but somehow maybe let's just take a guess. Luxury car is let's say 40,000. Okay, then you calculate the difference, right? The difference is equals 40,000 minus 15,000, so it's equal 25,000. Okay, and then you put this difference value here. Difference value. Okay, go to here. Go to this value. Okay, you need to check whether it's lower than Q, in the middle of Q and P, or higher than P. Okay, here, here, or here. Okay, so in order to know that, you need to define what is Q, what is P, so that you know which area it belongs to, right? Okay, let's say this is another parameter need to be defined by the user of this method. Let's say the Q is 5,000. Q is Q is 5,000. P is 15,000. Let's say, for example. Okay, if this is the case, so it means where does this difference belong to? It will belongs to more than P here. Okay, more than P here, you see that the score, okay, more than P here, see, the score will be equal to 1. So if you have a car that have the difference more than, let's say, 15,000, so you will prefer those car in terms of the price. Okay, this is one example. So the next step will be like, yeah, this is one example, another example, which there is several linear function can be used. For example, the first one here, you have Q and Px equal to 0, where it means that whenever you have the difference, a slight difference, you will give those, you will prefer that particular new option. here is Q and P, and Q will be equal to 0, P will be something. So it means that, okay, whenever have difference, you will have some preference, but the preference will become absolute or strong preference after one threshold called P or P here. And the last one is that the preference function is a step function. It means that if the difference is from 0 until Q, it will be no preference or 0. From Q until P, it will be 0.5. Yeah, from QQP, but more than P will be equals to 1. Okay, that's how do you use the function. Now let's take a look on the example. We mentioned about price earlier, right? Let's assume now we will have the preference degree with Q is equal 2000 and P is equal 5000. So Q is here, P is here. Now you just need to check the difference. Let's say, for example, here, for each of the alternative, economic, sport, luxury, touring. Here is economic, sport, luxury, touring. Okay, economic with economic, of course, it will be 0 because it's the same alternative. So here all of the diagonal will be 0. And then now we will start to, let's say, calculate economic and sport here. The price of economic is 15,000. Sport is 29,000. So you will have the calculation will be 29,000 minus 15,000. So it's equals to 14,000. Now you go to see where this 14,000 belong to. Okay, this 14,000, if you go to here to this preference function, oh, it's this part, right? After 5,000, so it will be somewhere here, somewhere in here. So somewhere here will be equals to 1, right? So that's why here you can see that when you have 14,000, you go to select the preference function. Sorry, the preference function is here like 1, and then you go back to put it here. Yeah, compare sport, economic and sport is equals to 1 because economic is strongly preferable than sport in terms of price. Okay, and you do that for all of the comparison here, and you will get this step. Next, you do for the sport here. Okay, then the luxury, and then the touring, all check with this function. And you can notice that here they have 0.5. How do you get 0.5? Well, actually here it's look like this. You can see that the difference between this one, touring and sport, right? Touring is 25,500. Sport is 29,000. So if you calculate, the difference will be 3,500, right? 3,500, 29,000 minus 25,000 will be divided by 25,000 minus the lower part, yeah, minus this, divided by 5,000 minus 2,000. So it's like the where this linear function will belong here. Okay, so we'll get 0.5. Okay, now the first step is complete. You will have this one, Unicriterion preference degree, consists of number from 0 to 1, show you the preference between one alternative to another alternative in terms of their one criteria. Okay. Next step. Next step, based on the table that we have there, okay, you need to create a graph. Okay, a graph called the that represent the preference degree here. For example, here, if you see the graph of the price, 0 mean the uh, uh, sorry, 0 means it means economic to economic. We don't have the graph. Economic to sport is equal 1 here. It means that you will have a graph that have an arrow from economic to touring here. And then next is that you have economic to luxury. Then you put another here, another graph have an arrow from economic to touring. Maybe I will draw it like here. This one go here. Okay, and then economic economic to luxury, economic to touring, you will have another graph here. Okay, economic to touring B, you have here this the graph. Economic to sport is this one. Okay, you see that this is the graph for economic, and after that you update the new graph for the sport. For example, from sport you only have one output, which is go to the luxury. So here sport to luxury here, and then luxury is, you see that luxury doesn't have any arrow, so they don't go anywhere from here in terms of price. And touring, you have go to sport, go to luxury. Touring A go to sport, go to luxury. Touring B, you see that they have 0.5 here, go to sport. So it will drawn in the unconnected line. It show the how strong is the relationship. Touring B to luxury is 1. Okay, from here you can see that, okay, economic car in terms of price doesn't have arrow go into that point. It means that in terms of preference, this will be the most most preferred among others alternative, because they have the strongest preference. From the graph you can see it. And luxury is the opposite of alternative being preferred in terms of price. Okay, and then you need to calculate all of that for the graph, and then the next step is to calculate something called positive, negative, and net flow. What are those? Okay, sometimes it is not easy to calculate if you have more alternative. The graph will be more and more difficult to understand. Okay, not easy to draw conclusion, from the graph because it's too complex. So what you need to do, you need to here we will be introduced with another measurement, so-called positive flow, negative flow, and net flow. So basically, positive flow is in the graph you will see it as a living flow, or the flow when you draw a graph or a line leaving the nodes into another nodes. Negative flow, it means also the opposite one, entering flow. Yeah, so it means that you have a graph entering the nodes, and you have an arrow entering the nodes. And net flow we will calculate based on the positive and negative flow. Okay, let's calculate. Okay, Here, let's do the positive flow first. Positive flow, here, if you can see that, let's take example again from the price Unicriterion preference degree. Here, you can see that in terms of positive, yeah, here, this is the leaving flow, right? You just sum all of this and take the average, then you will get this one. Okay, yeah, 1 2 3 4 1 2 3 4 5 divide sorry, because the diagonal one doesn't count, this one not count, so 1 2 3 4 divided by 4 is equal to 1. Okay. What about the negative flow? Negative flow you calculate based on this one. Okay, you put 1 2 3 4 plus divided by 4, so you get 0. Net flow is positive flow minus negative flow. Here you go. Okay, now let's take a look another one that is the calculation may be more complex. For the, what is it called? Sport car here, the positive flow, you have how many? 1, wow, so the diagonal is not count, right? So here, 1 2 3 4. So you only have 1. 1 divided by 4 is 0.25. What about the negative flow here? Negative flow. So you have 1, 2. So not that one. It's this one now. This one. Okay. So you have 1, 2, 3, 4 here. 1 plus 1 plus 0.5. So 2.5 divided by 4 is this one, 0.625. And then 0.25 you minus with 0.625, so you get this one, minus 0.375. So this is called the positive, negative, and net flow. Okay, you do all the calculation, and then you will get this one, positive, negative, and net flow for what? For price criteria. So this is only for price criteria. Okay. And next, maybe here is the explanation of our negative and net flow. And then after that, you can rank. Okay, you can rank the this one based on what? Based on their net price flow. Okay, you can see that in terms of price, the comparison is here, right? The economic car will be the first one. The economic car will be the first one, and then the sport car is second one. After that, you will have touring B, and then touring A, and then the sorry, this one is the economic here, luxury. The luxury is here. The luxury is here. So you can see that the most expensive one is the luxury. Second one is the sport. The third one is touring B. Third one is the fourth one is touring A. The most cheapest one is the economic one. Okay, you have this sequence, and then you see that from the net flow of the table that we generate here. You see that because we compare it in terms of price, that's why the economic one will become the first one, the most preferable. The second one will be the touring A, and then touring B, and then sport, and then the one that less preferable is the luxury car. Yeah, that's how you use this ranking. Okay. And then yeah, now you that compare all of this, all of this price, comfort, and then the the other preference criterions. Let me open the Excel here. Okay, you have this one. You only compute the price, and then after that you need to do for all of the comparison, the consumption, and then the comfort, and then the power, and then you calculate all of that, all of the net flow, net flow for price, consumption, comfort, and then power. Okay, and then you need to calculate. Yeah, that I go back to the here. After you calculate that, all of that is in a separate way in each criteria. Now you need to calculate for the global flow. So you take average from all of it. Okay. And beside that, we also need to have here this table, which is the parameter where you define weight. Okay. So for each criteria, you will have the weight that you need to determine first, and then you need to have to have those calculate those criteria. You need to use the minimum and maximum, or lower limit and upper limit of the preference, and based on this you calculate this part. Okay, this is called global flow. Okay, then next, after you have the net flow for the global flow, you have positive flow, negative flow, and then net flow, right? Now we move on. How do we decide? Okay, for Promethee 1, you use the information from positive and negative flow, okay, to create the ranking. Okay, how do you do that? So you will have a graph like this, which shown that we will rank based on the positive and negative flow. So it means that, for example, here, the one that is the most superior one is the Turing B, Turing B, this one, Turing B, where the positive flow, we want to maximize the positive flow here, Turing B, but we want to minimize the negative flow here. So compared to the other one, this one is the most the best one. Okay, so for this one we can easily choose the Turing B. However, if the global positive and the global negative score is not always like this, so one is bigger, one is not, so we will say that this is incomparable. Okay, incomparable here, since one is lower, for example, let's say for negative they lower, but for positive they are not that higher. Okay, so it's incomparable. So you need to decide. It is not easy to detect if you have these two comparisons. So next, later on we have Promethee 2, where we only compare based on the net flow. So we will like have the rank based on the net flow, the highest to the lowest one. Okay, this is still the same, where we have Turing B is the highest one, and then later on we have Turing A, and then on everyone until the last one is the sport card. Okay, next we also, if you use the software called Smart Picker, there is a graph called Gaia plane, in which it is combining the criteria, which is consumption, price, power, and then comfort, and the alternative here. See, what does it's shown here is the way you can understood is here is like, whenever you have here, for example, one is closely related to each other, it means they have the same characteristic. And then, for example, here, in terms of power, yeah, you see power here, sport will be the best one. In terms of price, economic is the best one. But in terms of comfort and consumption, touring A, touring B will be quite similar because they are in the same group here. Comfort, luxury, luxury will be about comfort and power. And then there is one arrow here called D. It's shown you where is the direction of the optimal solution for this problem. Okay. Yeah. And then, yeah, sensitivity analysis is about changing several parameters like wake, like Q and P. It will surely affect the result of this Promethee algorithms. Okay, I think that's the concept. Later, we will try to use Excel and then Smart Picker to solve this problem. Well, I hope you can understand this part so that later we will able to discuss more clearly when we have the example.